Welcome to Pomodoro Joe for Monday, May 29th, 2023. Today we're doing LeetCode problem 1603, Design Parking System. This is an easy problem. Design a parking system for a parking lot. The parking lot has three kinds of parking spaces, big, medium, and small, with a fixed number of slots for each size. Implement the parking system class. Parking system int big, medium, small initializes the object of the parking system class. The number of slots in each parking space are given as part of the constructor. Bool add car int car type checks whether there is a parking space of car type for the car that wants to get into the parking lot. Car type can be of the three kinds, big, medium, or small, which are represented by 1, 2, and 3 respectively. A car can only park in a parking space of its car type. If there's no space available, return false. Else park the car in that space and return true. All right, interesting. So a small car can still only park in a small space. It can't park in a medium or big space. So this is actually pretty straightforward. All right, we will put 25 minutes on the Pomodoro timer and we will get started. Okay, so in the initializer, we need to store this data, the big, the medium, and the small. So that means we'll need sometimes these are called member variables, sometimes they're called properties, but we'll need to store the big, medium, and small variables inside of our class. So in Python, to do that, we just say self dot, and we can say big, medium, or small. So we can do something like this, big is equal to big, self dot medium is equal to medium, and self dot small equals small. So that will store these variables as a property or a member of this parking system instance. So this is one way we could do this. And then in here, we can just check to see if the car type is big, then we'll reduce our big by 1 and park the car. But this is going to lead to a lot of if statements because we'll need an if car type equals big, etc., etc. Now, to avoid doing this big if statement, we know that this car type is going to be a 1, a 2, or a 3, which sounds like indices into an array. So that's going to be our plan here. We're actually just going to create an array to store our big, medium, and small. Then we'll use the car type to index into that array. So instead of having this, we'll just say self slots, and we'll have an array here. Now at this point, we have a couple different options. I think I'm just going to go with big, medium, and small. Because big is mapped to 1, medium is mapped to 2, and small is mapped to 3. Now, these will be 0 indexed. So big being mapped to 1, this is actually mapped to index 0. Medium is index 1, and small is index 2. So we'll have to do a little bit of math to convert our car type into our actual index here. But that's pretty straightforward. So we're storing our slots in our self slots. Then here, we'll create our index. Now our index will just be our car type. Now let's see. It's either 1, 2, or 3, but our 1 has to map to a 0, our 2 has to map to a 1, and our 3 has to map to a 2. So that's just car type minus 1. Now that we have our index, we still need to use it to check to see if we have any spaces of this type left. So we'll say if self.slots. Now you still need the self here. At this index is greater than 0. That means we still have some slots for this particular type. So now we'll park this car, removing 1 slot from our inventory here. So self.slots at this index minus equals 1 because we're taking 1 away. And then we can return true because we were able to park the car. Otherwise, we weren't able to park the car. We had 0 spaces left. We'll return false. So this is pretty straightforward. We'll store some array of our spaces. Then when we add a car, we get our index from the car type, check to see if we have some spots of that type available. If we do, we'll remove 1 from our inventory after we park the car, and we'll return true. Otherwise, we don't have any spots available for this car type, and we return false. So let's try this. That works. Let's see how we do. It works, and it works very well. We beat 91% for runtime and 15% for memory. So yeah, that works great. Now we'll jump back really quick and I'll show you one thing we could do. So right now we have these slots, big, medium, and small, but our big is mapped to car type 1, medium is mapped to car type 2, small is mapped to car type 3. Wouldn't it be nice if we could just use our big, medium, and small as the index itself, or the car type as the index itself for big, medium, and small? Well, one thing we could do is we could pad our array here by just adding some value. So for instance, 0. Now if we pad our array, this 0 doesn't really mean anything. It's just taking up the place at index 0 so that we can actually index into big with index 1. So this index won't have to be created. We could just use car type directly. So that actually saves us one line of code, one operation for subtraction, but it does allocate more memory for this slot. It could be up to 25% more memory, considering we only had 3 or 33% more memory, if you think about it. But that's the trade-off here. More memory, maybe a little bit faster in terms of calculating our index here. Let's see if it still works. All right, let's see if this changes our outcome. Oh, and it helps us. So we actually beat 96% now for runtime and 44% for memory. So not only does it help us in runtime, but we actually do better in memory. I'm a little bit surprised by that, but that's awesome. So 96% runtime, 44% for memory. This is a great solution, if I do say so myself. All right, well, that is it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.